Here we go, mathletes. We're going to talk about, we're going to find ways to use algebra to evaluate limits in this lesson. So we talked about limit laws last time, and sometimes we can use direct evaluation too, right? Remember, direct evaluation works when a function is continuous. So when we have a polynomial, those are always continuous, and so we can just plug in a value. However, if we have a rational function, those can be continuous as long as the denominator is not 0. But in this case, if I try to find the limit as x approaches 1 of f of x here, that poses a problem, right? Because if I just plug in 1, I get a 0 in the denominator. So that's a situation where we have where we cannot use direct evaluation, right? In fact, if I plugged in 1, what I would end up getting is, if I did f of 1, I would get 1 squared minus 1 over 1 minus 1, right? So 1 squared is 1, minus 1 would be 0, so we end up with a 0 over 0 situation. Okay? Now, a lot of times when you have a 0 over 0 situation, you can simplify, and you can find another way to do it, and this is where algebra comes in, okay? And so what we can do here is we can factor, right? So I can say, all right, well, f of x, instead of x squared minus 1 on top, that's a difference of 2 squares. So I can make that into x plus 1, x minus 1, right? And then the bottom I have x minus 1. So it turns out that we have these two binomials that are exactly the same, and they can cancel out. And so what we have left is x plus 1, right, which is the same as over here. And notice how the lines are exactly the same, right? The graphs are exactly the same except for this little hole right here, right? That happens at x equals 1. And so at that point, it doesn't exist, but the limit can still exist, right? And so what we do is when we have a 0 over 0 situation, we can try to algebraically manipulate it and simplify. And at that point, now we can do a direct evaluation where we say, okay, let's plug in 1 here. And what we end up with is 1 plus 1, which is 2. And so, so we can see that the limit as x approaches 1 of this function f of x is actually 2, even though the function doesn't exist at that point, right? Even though there's a hole in the graph at that point, we can see it clearly from the graph that from either side we approach 2, right? As we approach 1 on the x-axis, we approach 2 on the y-axis. So we can see that graphically, and this is how we can arrive there algebraically. Okay. All right. So here are some strategies. So when we have a situation where we have two functions that we're dividing, so some type of rational expression or function, and it ends up turning into 0 over 0 if we directly evaluate, then what we can do is, we check to see that our function in the appropriate form cannot be evaluated using limit laws, right? Okay. And then we try to find a way that to get this function, f of x over g of x, to equal h of x, where we can evaluate, right? And so one way we can do that is we can factor each function and cancel out any common factors. That's what we just did, right? So that's A. Or if we have a square root, then we can try multiplying by the conjugate. Okay, so we should try multiplying the numerator and denominator by the conjugate. And I'll show you that. That's something you may have seen in Algebra 2. And then finally here we have C, which if we have a complex fraction, then we're just going to simplify it, okay? All right, and then once you get there, then you can apply the limit laws. Then we can get to a point where we can actually evaluate the function, just like we saw in the last example. All right, so those are the things that we'll explore. We'll try to look at, okay, how do we factor and cancel, just like the one we saw in the first one. We'll check out some different examples, and then if we have radicals involved, or square roots especially, we can multiply by the conjugates, and we can simplify that way. And then if the last one is if we have a complex fraction, meaning if we have a fraction within a fraction, then we can try to simplify by getting common denominators and and kind of simplifying that fraction into just a single fraction, or maybe even it simplifies further than that.